honestly, this is a good excuse to realign your tailstock, which you should be doing periodically anyway. But you aren't, are you? I know you're not. Hello Internet, my name is Quentin and this is Blondihacks. Today let's talk tapers. Why are they so prevalent in the machine shop? Where do you use them? What are the advantages? And most interestingly, how do you make them? In the machine shop, tapers have three critical properties that makes them so ubiquitous. The first is that they are self-aligning. The more you push on them, the better centered they become, so they have automatic accuracy built into them. Second, they can be self-holding, so they can hold tooling in a very convenient way. And third, and not to be underestimated, they're very easy to manufacture. Remember that most machining technology was invented 100 years ago, and we've been just refining it ever since. And so these are parts that could be made with much more primitive machinery than we use today. But even though we have fancy machines nowadays, these are still desirable because precision and complexity costs money, and the simple taper is very, very inexpensive to make. Machine tapers come in two major kinds, the self-holding type and the self-releasing type. So self-holding tapers are generally those under 16 degrees of angle. The most common, for example, the Morse taper is much, much less than that. It's on the order of 2 or 3 degrees. Now something like a collet is a classic self-releasing taper. This is the Bridgeport R8 standard. This angle here is 16.5 degrees, and so that's greater than that dividing line, and that makes it self-releasing. Now intuitively, you can kind of see how these work, right? If you'll live long and prosper with me for a moment, you can imagine the matching taper here, and because this angle is very slight, you've got a lot of static friction forces in here, and the harder you push on that, the tighter it's going to get, and it's difficult to pull out. But the greater this angle goes, the less secure that grip is going to be, because the angle of friction is getting closer and closer to orthogonal, and of course the end game of that is a perpendicular surface which has no stiction force. So somewhere around 16 degrees is the dividing line on that, where the taper wants to pop out more than it wants to stay in. So while the self-holding taper is great for things like tailstock tooling in your lathe because it'll stay put, on something like a tool holding collet, we want the self-centering advantages of the taper and a little bit of that holding. It's nice that the tool kind of stays there when you loosen the drawbar, but we do need a drawbar to hold that taper in there because it's not self-holding. And of course, in the case of collets, the other advantage to tapers is that the more you draw them in, the smaller the diameter gets, which then closes up the splits in the collet. But that's just kind of a nice side effect. Really what we're here for is the alignment. Now I'm going to show you how to cut tapers, and I'm going to focus on machine tapers because these are the most challenging for a hobby machinist to cut. But what I'm going to teach you is the same for all types of tapers. So even if you're doing just decorative chamfers on things, or non-critical surfaces, or sealing cones in pipe unions, that sort of thing, all the same techniques apply. But I'm going to focus on these very long, very slight tapers, which can be challenging to cut on hobby equipment. We need to start by figuring out the angle that we need, of course, and for machine tapers, Machinery's handbook has all the info that we need. Now you might be expecting to see angles in here, but what you actually get is taper in thousandths per inch. Now, sorry about the imperial units here, folks, but all the techniques that I'm going to describe here apply regardless of your system of measurement, so bear with me on this stuff. On this topic, it's just too tricky to convert back and forth for you all the time. For this example, I'm going to be making a Morse taper 2, which is a convenient one because it's effectively 50 thou per inch of taper there, as you can see. This is a convenient number for this demonstration, and if you're on a small hobby machine, Morse taper 2 is probably extremely useful for you. Your tooling probably all uses that. The other number you're going to want is this here, which is the big end of the taper at the mating point with the socket. Keep that in mind, we're going to be using that later. So why don't they just give us angles here? It turns out that diameter change per unit of length is actually what you want when you go to set up the machine accurately to cut a taper. The first method I'm going to talk about is, of course, using the compound, which is the most convenient and straightforward way to cut tapers. However, on hobby equipment, this is often a limiting factor because one of the places that they cut corners on these low-rent machines is on the travel of the compound and cross-slide. So you may not have enough travel to cut a long machine taper like a Morse taper. Morse taper is typically 2.5 inches in length, the relevant mating surfaces, and my lathe has just barely that amount of travel on the compound. It's a little short of that, but we can just barely get away with it. So something to think about if you want to try this method. method. To get the angle correct on your compound, for a lot of basic tapers, especially aesthetic ones, you can just use the markings on the compound itself. They're going to be good enough. If you need something a little more accurate, like a sealing surface for a pipe union, something like that, then a protractor will suffice. And you can just square it up against something like the face of the chuck there. You can squeeze a little more accuracy out of it by putting a light under the mating surface of the protractor there and just check for a gap, rather than just relying on feel. And this will get you within a degree or two. However, for machine tapers, this is typically not accurate enough. Another approach you can use is to find the taper you want to cut on something else and copy it. So in this case, I've got my dead center that has a straight section here at the end, and that means I can chuck it up in my forejaw. You can often do this with machine tapers because you probably have something else in your shop that has that standard machine taper on it. So I've got the copper soft jaws in there, not so much to protect that area of the dead center, but to allow me to shift the part around easier, as you'll see here. So I start by dialing in the root end of the taper, as you would expect, and get that running as true as you can. Then go down to the far end, and that's likely to be running out because it's unlikely to be perfectly straight in the jaws on your first attempt. So next, we need to straighten this end out using our tappy tap tap hammer, just gently tapping that in until that end is running, again, as true as you can get it, within a few tenths if you can. And then once that's running dead straight, then you got to go back to the other end, and there's probably some run out in that end again now. So we've got a couple thousandths of run out reintroduced in this end, so we take that out. And you'll likely have to go back and forth a couple of times, tapping in the far end, dialing in the near end until both ends are running dead nuts straight within a couple of tenths if you can. Now we're ready to read this. The reason that we have to be so careful with dialing that in is because obviously if the run out on this is not as close to zero as we can get it, then the angle that we're about to copy isn't going to be the true angle. It's going to be something a little bit off because the part is not spinning. We're using it as a stationary reference. So dialing it in is a proxy for getting it very, very straight. Okay, let's get set up to copy that taper. So I'm going to swing the compound around and line it up with that taper angle just by eye. Your eyeball will get you pretty darn close. And then at this point, you can check at the back and see that you're going to have clearance around the tailstock to do this. This is one limitation of using the compound in this way. At slight angles on a lot of lathes, it may interfere. You may have to extend the tool in the tool post or things like that to gain clearance. So the time to find that out is now. Now bring in the dial test indicator. It has to be set up on the compound so that it's moving with your compound. And then you're going to put it on the front surface of the taper. It has to be on the front. I'm using a half thou indicator with this, which is sufficient for cutting functional machine tapers. A tenths indicator would be better, but those things are a little crazy making, and I don't recommend it for your first attempt at this. And now I'm just going to tappy tap tap this in until the indicator reads 0 all the way across. I'm using the same approach as the rapid method for indicating a vise on a mill, which is that you move the indicator back and forth and you're watching the motion of the needle, not the value that it's reading, and you're trying to get the needle to stop moving. So you keep tapping it in one direction as long as it's slowing down its travel as you go. And that way you can close in on 0 quite efficiently. One tip when tapping on a slide to move it, tap on the lower portion of the slide, the stationary part. If you tap on the upper part, it shakes the needle more, and any play that's in the gib acts as a shock absorber, and so you can tap all day and nothing seems to happen on the needle. So tap on the lower part of the slide. Once you've got that dialed in to where it reads 0 as close as you can anyway, all the way down the length of your travel on the compound, then you're set to go. You can see on a budget lathe like this, there's more than a few tenths of play on the compound, even with the gib properly adjusted. So do the best you can here. All right, let's make some chips. So I've got a piece of cold rolled free machining steel here. It's extra long because I'm going to be making 2 tapers. And I'm going to push this all the way into the forejaw and face off the end, as is tradition. The nice thing about this method is that you can do it in any old chuck that you have. I'm using the forejaw here because it happens to be on the lathe. Now I'm going to pull the stock out and dial it in so that I can get a nice concentric center in there, which I will punch in now. Doing the center drill while the stock is pulled out will compensate for any bend or crookedness that might be in the stock. And now we can turn it down to the major diameter of the taper. So referring back to that chart in Machinery's Handbook, it shows you what the diameter of the taper should be just outside the mating surface of the socket that the taper is going to be fitting into. So that's your target for cutting the stock down. Side note, while I'm making chips, I won't be discussing taper attachments in this video, which are of course a fancy way to make tapers, but Most hobbyists aren't going to have one of those, and most hobby lathes don't even support them. But you may have seen them. It's a contraption that hangs off the back of the lathe bed and automatically moves the cross slide in and out according to an angle that you set as you move the carriage. Pretty neat if you've got one. Getting ready to touch off on the small end of the taper now. Make sure to wind your compound all the way back before you do this, because you're going to need every millimeter of travel on that compound on a small lathe to cut a functionally long enough machine taper. And then touch off, dial in some depth of cut with the cross slide, and start feeding. And because we're cutting a taper, you'll see, of course, that the cut will fade away to 0 relatively quickly. So that's one pass. And then just proceed to dial in subsequent passes, feeding with the compound. This footage is sped up because feeding with the compound is pretty slow and tedious, but you can see that with each subsequent pass, the taper gets much longer pretty dramatically because it's a very low angle taper. So it doesn't take very many passes before you're almost at full taper length. To find your final diameter, it's actually enough to approximate this just by doing your best to grab the very edge of the small end of the taper with a caliper or micrometer and just look up what that diameter should be in the tables. The actual diameter here doesn't have to be that accurate unless the lateral position of the taper when seated matters, which in hobby machine work never does. If you get this end too small, it just means the taper will sit a little deeper than it perhaps should, but it's the angle that matters much more than the diameter at the small end. Once we're at diameter, I'll chamfer the back edge there a little bit just to smooth the transition into the socket, because now we can do a test fit. Conveniently, I'm cutting a Morse taper 2, which is the same as my tailstock, so I have a convenient go-no-go gauge built into my lathe. So I'll just remove the center and slide that on there and see how well it fits. And, well, that fits extremely well, actually. I'm struggling to unlock that. Pro tip, slide it on there lightly when you're just first doing your test fits, because you may have trouble getting it off if you've done your job right. In this case, I had to actually get out a brass drift and tap that collar off of there. You can't use the normal eject system of the tailstock of winding it in, because you can't pull the tailstock in close enough to the chuck to do that without, removing the carriage. That fit seems great, but it's also worth adding a little bit of extra clearance at the big end. Just find this spot where your taper ended. You'll be able to see it from the tool marks. Just take another 1/10 off of that, just to make sure that the big end is not interfering with the taper seating all the way down. But cards on the table, if you really want to know how well you did, it's time to get out the Prussian blue. This is a machinist goo that's basically like Dicam layout fluid, except that it doesn't dry. It stays gooey, and it allows you to check the fit of mating components. So just smear a very thin and even layer on there, as thin and as even as you can get it. Don't get this stuff on your clothes or your skin, or you're going to be pretty blue about that for a while. Now we can do the test fit again, just gently. Don't ram it on there, just gently seat that taper in there and pull it apart again. This time I was able to crank the quill back because I didn't jam it on there quite so hard. And now you can turn it around and see how well those tapers are mating. So you can see that I've got really good coverage around the top here. Everywhere that the blue is thinner or worn away is where the tapers are meeting. And then there's good contact down here on one spot, and an area back here is pretty good. It's pretty hard to show on camera. It's easier to see in person. But overall, not too shabby. It's not great though. And that's the limitation of this compound method. It's convenient, but it is not as accurate as the next method that I'm going to show you, which is the tailstock offset method. So let's part this guy off, and I'll save that. A Morse taper 2 is always a good thing to have for future tooling projects. Put that in the drawer, and let's do another one with the more accurate method. I'll face this off once again and punch a number 2 center in there. Now, we're going to do something different. I'm going to take the stock out, flip it around, face the other end, and put a center in that end as well. The reason being, we're going to be turning between centers. When you're offsetting the tailstock, you have to turn between centers because, of course, the part is crooked relative to the lathe. So you can't use any form of chuck for work holding because you can't hold something crooked in the chuck. So set up my standard turning between centers setup here. I've got a lathe dog driving the chuck end there. And now I'm going to go ahead and turn down to that major taper diameter again. And you need to do this between centers for reasons that you'll see here in a minute. When you're at the major diameter, make sure that as good as you can possibly get it, there is no taper in this part. Measure it in multiple places and really be sure about this. If you need to tune it up a little bit, use some emery cloth or make some additional cuts as needed. You really want this bar to be dead nuts straight and no taper all the way down. In this case, I'm about 6/10 large at the far end, so I'm bringing that down with emery paper. The more accurate you get this step, the more accurate your final taper is going to be. That diameter is so critical because it's going to be the reference for getting our angle set up on the tailstock. So this is the 2 indicator method. I'm setting up an indicator on the cross slide and also one on the carriage. And the one on the carriage is a long travel indicator. I can measure a full 2 inches on this, which is the distance that I'm going to measure. The more distance you can measure here, the more accurate your angle will be. So to start with, across the entire 2-inch travel, the cross-slide indicator should, of course, not move at all. Forgive the parallax error on the camera there. That needle is on 0. I know it doesn't look like it, but the point is that it isn't moving. If you don't have this as a starting point, then keep tuning up your surface until you do. Now it's time to loosen the jack screws on the tailstock and start shifting it. So we're going to be moving it towards the indicator to make that end smaller, and we're moving it according to the numbers in the tables in Machinery's Handbook. Morse taper 2 is 50 thou per inch of taper, so we're measuring over 2 inches, which is 100 thou. However, we're only measuring one side. We're measuring the radius change with that indicator, so it's back to 50 thou. Easy peasy. Then we double check that by moving the carriage down exactly 2 inches using that carriage indicator, and then we should see the cross-slide indicator stop at exactly 50 thou. So you can go back and forth and tune this a little bit until you get that result. So you can see I'm a little short there, but after some tuning, here's the full 2-inch travel. And you can see, again, sorry for the parallax, but you can see that we're dead nuts on 50 thou. So that should be the correct taper. And lock that tailstock down and start turning. And from this point, it's just a standard turning operation. What's great about the offset tailstock method is that you can use your normal carriage power feed and you'll get a better surface finish that way, which also results in a better fitting taper. The better the quality of the finish, the stickier that taper will be. And the 2 indicator method, of course, can be used with the compound as well, but you're always going to be limited by the quality and travel length of the compound dovetails on small lathes like this. So if you need a good quality machine taper, honestly, I'd just go straight to offsetting the tailstock. Furthermore, if you have a carriage DRO, that's nice for this because you can use that to measure your carriage travel when setting up the angle. That will also allow you to measure more than 2 inches of travel, and the more carriage travel you can measure over, the more accurate your taper will be. Indicators are pretty limited in how long they can get. Once again, we estimate the final diameter on the small end as before. Now we can pull the stock out and I'll test fit on my tailstock again. That certainly seems good, but the Prussian blue will reveal the truth here. Once again, jam that in there, not too hard so you can get it out easily. Note that Prussian blue is a lot easier to read on the other surface. You can see where the blue transferred to the mating surface, but with a small Morse taper 2 socket, it's kind of hard to do that. And you can see right away we've got quite a bit better fit. We've got a much wider band of solid fit right at the base there, and then further towards the small end, we've got some wider sections here that have really good contact. There's an area around the back there that doesn't have much of any contact, but overall, this is much better. One of the great things about tapers is that they are fairly forgiving on this. You don't have to have perfect seating all the way around to get good performance. To prove that point, here's the commercial taper I've been showing. Let's blue that up and see how it does. You can see that this has got a good strong contact patch along one side there. On the other side, there's almost nothing. So in some ways, we're better than the commercial taper here because we've got a nice wide band all the way around, which is going to be better for concentricity. This commercial one probably holds a little tighter because it's got a lengthy contact patch there. But point being, hobby-grade commercial tapers are not necessarily that good either. And a machine taper doesn't have to be a perfectly concentric precision ground masterpiece to be perfectly functional. Remember, this is the worst of the two, and I almost had to dismantle the quill to get this thing apart. Of course, after all that, you have to get your tailstock straight again. And I think this step scares off a lot of beginners from trying tailstock offset turning. It really shouldn't. Get yourself comfortable with messing up your tailstock and fixing it again. Because honestly, this is a good excuse to realign your tailstock, which you should be doing periodically anyway. But you aren't, are you? I know you're not. Anyway, I've got a video on this procedure which I'll link to below for aligning your tailstock. But once you've made yourself an alignment bar like this process is really very quick. And you should get comfortable with moving your tailstock whenever you need to. Cutting machine tapers is a really powerful skill to have as a hobbyist. It opens up all kinds of worlds of making your own tailstock tooling. You can make your own collets, all sorts of stuff. So I recommend giving this a shot. Get comfortable with it. Thank you very much for watching. Thanks to my patrons for making all this possible, and I will see you next time.